Can the conservation of mass change? Frequently asked questions. When can the conservation of mass change? Conservation of mass remains valid for reactions that are commonly observed. But mass gets converted to energy in some reactions. When a radioactive nucleus undergoes a nuclear reaction like fission or fusion, a tiny amount of mass is lost. The total mass before and after the reaction does not remain the same. The lost mass is converted to energy, and the expression for determining the energy released is given by the Einstein's equation. E equals mc squared, where m is the difference in mass in kg, c is the speed of light in vacuum in m/s, E is the energy produced. The change in mass might be very small, but the energy released may be enormous. How can the conservation of mass change? Conservation of mass is subjected to variation in certain contexts. For nuclear reactions, the conservation of mass becomes invalid and instead, total energy remains conserved. The strong nuclear forces are overcome during a nuclear reaction and a tiny mass is converted to energy. Therefore, the change in total mass before and after the reaction is liberated in the form of enormous energy. According to the law of conservation of mass, matter cannot be created or destroyed, it can only be rearranged. But Einstein proved that conservation of mass is not valid for all reactions. There are reactions where mass gets converted to energy and hence conservation of mass principle is modified to conservation of mass energy. Although this is true for ordinary chemical reactions, since the change in mass is too negligible to be noticed, the mass conservation remains valid for ordinary reactions. Why the conservation of mass change? In general, mass conservation principle demands that the total mass or amount of matter before and after a chemical reaction remains the same. Balanced chemical reactions are a result of this mass conservation principle. However, in nuclear reactions and some astrophysical phenomena, conservation of mass is violated as some mass gets converted to energy. According to theories from relativity, mass-energy conversion is common in all reactions. However, in ordinary chemical reactions, the mass difference prevalent between all the reactants and all the products is of the order of 0.1 parts per billion or less. As a result, mass seems to be conserved in such chemical reactions. Whereas the mass difference can reach the order of 1% in nuclear reactions, and hence conversion of mass to energy is clearly evident. Where the conservation of mass change? Whenever the concepts of relativity approach, the conservation principle is not valid. Nuclear fusion reaction, i.e., fusion of hydrogen to helium taking place in the Sun and other stars, as well as during some astrophysical phenomena like black hole mergers, mass conservation principle gets violated. The thermonuclear fusion process happening in the Sun is the most common example where mass conservation is invalid. During the process, some parts of mass gets converted to energy, which is the energy we receive from the Sun. Einstein developed a formula for quantifying the amount of energy produced from a specific amount of mass. The formula is E equals mc squared, where m is the mass and c is the speed of light. Since the formula contains C2, a small amount of mass results in a substantial amount of energy. For example, 1 kilogram mass generates 900 billion joules of energy. That is why in nuclear reactions, tremendous amount of energy is released. Hence, instead of conservation of mass, Einstein put forward a theory of conservation of mass energy, wherein total mass and energy remains constant. This principle is also known as mass-energy equivalence. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. scientific calculator, and many more other tools.